The more you practice these, the more they'll stick. This goes right 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I would start here. I'm not going to be able to fit much of this parabola. Over 1 squared is 1, and then I'll do 2, 1, 2, 3, 4 on either side. And then that one's kind of off the graph, so that would be the parabola that's been shifted right 9. So I'd like you to add the other 2 parabolas, B and C, and then when you look down below, those parabolas have been shifted up and down. So see if you can, you're graphing 6 parabolas. Try to commit it to memory. So I'm going to good at drawing those parabolas now, right? So I go left 2, so left 2, up 1, over 1, and then let's see, over 2, up 1, 2, 3, 4. I could go over 3, up 9, but I'm going to be lazy. I'm just going to plot those points. And then let's see, this one is right 5. 1, 2, 3, 4, 5. So there's my vertex there. 1, 1. Over 2, up 1, 2, 3, 4. Oh, they intersect each other right there. That'd be a good question. Where do these parabolas intersect each other? Right at that point, right? They shared that point in common. All right, then down below, you should have 3 parabolas that you just shifted up or down. So this one was up 8. 2, 3, 4, 5, 6, 7, 8. Not much of this parabola is going to fit. So I'll just go over 1, up 1, and kind of draw my curve. And then minus 5, you should have started down 5. 1, 2, 3, 4, 5. And then you're practicing over 1, up 1, over 2, up 1, 2, 3, 4. So you're getting lots of practice with drawing that smooth curve. Let's see, x squared minus 10. So I got to start all the way down here at 10, negative 10. 1, 1, over 2, up 1, 2, 3, 4. All right. Here's something we never got to in our inequalities unit, but I wanted to. We just never really had time to do it. But what if I said y is less than or equal to x squared plus 8? You don't have to draw this on yours, but I would shade below that parabola, right? So if it's less than x squared plus 8, I would shade below that parabola. And I can actually continue shading like all the way down here, right? What if I wanted to shade above? So what if y had to be greater than or equal to x squared minus 5? Then here's my x squared minus 5 parabola going up. I would have to shade above that parabola. So see how you can still get the intersection of 2 inequalities even if you're shading with a parabola curve? So here would be where they intersected, right? They had to be below this parabola but above this parabola. So the black and green area would be the intersection of 2 different inequalities. That might be a good bonus question, having you shade a quadratic inequality, because now you know how to graph a quadratic. So I just think it's interesting to think about, because we studied linear inequalities, you could also have quadratic inequalities. And I've seen them on SAT as well, so thought I would mention it. Okay, I wanted to skip to, was there any problems on 210 that we skipped? There were 2 on the back page, right? So the practice from yesterday, this says convert from vertex into standard form. Standard form is what we're doing today. This is really just multiplying out the using FOIL, right? So let's do one of them together and then you can try the other one. But do you remember how to write this out? When it's x plus 5 squared, we cannot distribute the squared symbol, right? We're going to write out x plus 5 times x plus 5, and we're going to multiply those 2 binomials together, either using the box method or the FOIL method. It seems like a lot of you skipped right ahead and you liked homework 2.5. You know how to multiply these out. So take a minute, multiply these 2 together, either using the box method. Oh, Noah, you weren't here, were you? So I don't know which way you prefer, but the box method is when you take x plus 5, x plus 5, and you write them outside a box, and then you multiply everything together in here. So x times x is x squared, 5 times x is 5x, x times 5 is also 5x, and 5 times 5 is 25. Oh, Parker, you weren't here yesterday either, right? Does this look familiar, like you multiplied these last year by any chance? So to write your final answer, I'm not done yet. I have 3 times, I need to write this as a trinomial. So I have x squared, 5x plus 5x is 10x's, and then plus 25. So there's a lot of steps to this problem. You got to be accurate with your algebra. Now you're going to distribute your 3 into the parentheses. So your final answer would be 3x squared. Then I have to do 3 times 10x, so plus 30x's, and then 3 times 25 plus 75. So this is the type of equation we're going to look at today. And this started out in vertex form. It'd be so nice if everything was just in vertex form, so easy to graph. But sometimes you're given an equation that is not in vertex form. So you have to have another strategy because I can't tell where my vertex is. Do I go left or right or up or down? I can't tell from this format. So try the second example, example 8. This one is a little bit different because first you are going to multiply x plus 4, x plus 4, and at the very end you're just going to subtract 8. You don't have to distribute something. Yep, the answer to each of these is an equation. So the other method, Parker and Noah, that I reviewed with them is just called FOIL. When you actually look at the equation and you do the first 2 terms, so you do x times x, which is just x squared, and you write it down. Then you do the outer 2 terms and the inner 2 terms and add them together. So this would give you 4x. This would also give you 4x. If you add them together, you'll have 8x. And then if you multiply this 4 times this 4, you get your last term. So 4 times 4 is 16. And then I have to remember I have to subtract 8 at the end. So y equals x squared plus 8x plus 8 would be my standard form answer. And I told them they could either do the box method or FOIL in their head. I don't know which one do you prefer, do you think? You like the box method? You've seen that one before? Great. So that's good. As long as you have one method to be able to multiply these binomials together. Thank you so much. All right, so let's skip and do something new today. We're going to look at standard form. And this is one of the last things that you are learning in quadratic transformation, graphing, all the things. So if you look at our agenda, morning, we've got a graphing quadratics quiz on Thursday. So today's Tuesday. We're going to learn how to graph in standard form. There's one little formula that you'll need. I'll write the formula on the board for you on Thursday. Tomorrow we're going to spend time practicing graphing. Take a quiz on the early release day because it's only like a 30-minute class. So we'll just kind of take our quiz. It'll be quick class, just like the quiz last week. And if you look, then I don't see you for 4.5 days, right? Because you're all going to get rested up, go to the fair, do all the fall things. We're going to come back on Tuesday. And did you notice what I wrote down we're doing on Tuesday? Did anyone look ahead? We're building catapults. So we're going to be practicing graphing and building catapults. And I kind of am splitting the review over a couple days because I know 4.5 days you're going to forget a lot. So we'll have kind of 2 partial days of review and 2 partial days of building catapults to launch ping pong balls. We'll take our unit test, and I may even bump our unit test to Friday, depending on how building catapults goes. And then we're going to be launching catapults and calculating equations. So the week we get back, we'll have those 2 days to review and also build catapults, because reviewing for 2 days straight would be kind of long and boring. So anyway, this is one of the last things that you need to be able to do this unit. So you've got your transformation rules and graphing quadratics. So the resource page that we skipped, I think, is our last resource page. So if you've been absent, if you flip through the first 1, 2, 3, 4, 5, 6 pages, those are the resources that should be all completed after today. If not, you want to go home and find the video from that day. Yeah, the first 6 pages. So the last page of the one is this one, Noah and Parker, that you guys missed. So you want to go through and fill this page in. That's the last of the resources, because after that, it starts with the practice page. Yeah, was there much to do on that page? Those were the transformation rules, weren't they? Let me see. I don't think there was anything to do, was there? So on this page, all it was showing you that when your coefficient's bigger than 1, it's a stretch, and there's the graph that corresponds with it. So there wasn't actually anything to fill in. Same thing on this page. This was just telling you to transform it up. It's a +2, and there's a shift here on the graph. So really, this is already filled in for you. There's nothing to fill in on that page. So, and then you get points, right, for having your resource pages filled in on the test day. Okay, so here's standard form of a quadratic. This is the last resource page, kind of the last new idea for this unit. So here's the equation, ax squared plus bx plus c. So it's kind of the ABCs. What does each part of that equation do? And I want you to compare it to, on the other page, we had vertex form. Remember, ax minus h squared plus k? So I'm just going to write that other equation up on the board so we can kind of compare the two. So we had ax minus h squared plus k. Now we have ax squared plus bx plus c. So I see one thing the same and two things that are different. My a term is going to stay the same, so it's going to have the same job. But h and k, those shifted left, right, up, down. B and C do not shift left, right, or up, down. They have two different jobs. That's why they get a different variable. But these are both quadratic equations, and we saw how we can make this equal this by multiplying it out using FOIL. So they're going to give you the same graph, but in a slightly different way. So A is your concavity, remember from last time, and it's also your stretch. So it's the same as before. Is it concave up or down, and what's your stretch? But B, so think of this as the ABCs. So B, you're going to use negative B over 2A to find the x value of your vertex. It is, so the quadratic formula is derived from part of that, yes. Because if you've already studied the quadratic formula, we'll get to this in the next unit. All over 2a is the quadratic formula, and it's going to find x-intercepts on a graph. But look what's snuffed in there. You know, negative b over 2a is sitting there. The reason is, guess where your x-intercepts are? They are equidistant from your vertex. So if we're using this to find our vertex, our x-intercepts are somewhere like on either side of your vertex, right? And there's actually a proof that you can see that shows that this will get you your x-intercept. So yes, unit 3, we're going to look at ways to solve a quadratic, but that is just getting the x value of our vertex. That's the formula that I said, I'll put this formula, negative b over 2a, up on the board on Thursday to remind you. But by the unit test, you'll have to have negative b over 2a memorized, because you're going to use it a lot to graph quadratics. And the c value is actually your y-intercept. Let's think about why that is true. If I'm sitting on the y-axis, what's my x value? No, what's my x value? Yeah, like if I'm at this point, what's my x value there? 0, 4. What if I'm sitting up here? 0, 10. What do you plug into an equation to get a y-intercept? You plug in 0. So that And if I plugged in 0 here, then that term just went away. What do you have left? C. A what? Oh, you're thinking of an axis of symmetry, right? Yes, so if x is 0, though, C is the only thing left, so C is my y-intercept. That's what I was trying to say. All right, so here's what you do. You do the ABCs, right? So ABC is like a way, simplifying it down. Do A first, then use B, then use C. So here's my equation. The first thing you should do is identify what is A, what is B, and what is C in this equation. There's nothing written in front of x squared. So what is A? 1. So when you don't see it, it is 1, or maybe -1 if there's a negative sign. What is your B value? Is -6. So the B value in this problem is -6, and the C value is +4. So I'm trying to draw those kind of bold so that way we know what our 3 values are of interest. 1, -6, and 4. So I'm going to do the ABCs. My A value kind of tells me these first two things. Is it concave up or down? Is it a vertical stretch? Compression means shrink, or is it the same as the parent graph? So what would you say, concave up or down? Up, because A is positive. Is it a vertical shrink, stretch, or is it the same as the parent graph? Same as the parent graph, because it's 1x squared. So now in your head, you're thinking about what this parabola is going to look like. So I just did the A. Now I'm going to do the B. So this part is kind of like your A, B, and then this is your C, ABCs. So equation of the line of symmetry and the coordinate of the vertex. That's where you're going to use your formula, -b over 2a. -b. So if I already have a -6, what's -b going to become? It's the opposite of b. So -6 is going to become the opposite, +6. So I'll have +6 on top, and I'm dividing by 2a, 2 times 1. So what is 6 divided by 2? 3. So my line of symmetry is at x equals 3, and the coordinate of my vertex also gets a 3, because 6 divided by 2 is 3. If I have an x value, how do I find a y value? I have the x value, what? Plug it in. So I'm going to take this 3, and I'm going to plug it into this equation up here. So I have to do 3 squared minus 6 times 3 plus 4. I'll write it out for you. So I took the 3, and I stuffed it into that equation into all the x's. What is 3 squared minus 6 times 3 plus 4? What's that give you? Anyone good with mental math? 3 squared is 9. 6 times 3, so -9 plus 4. Did you say -5? Correct. So 3 comma -5 is my vertex. That was a lot of math to find the vertex. Guess how this equation could have been written for you? It could have been written y equals, how do I go right 3? X minus 3 squared. And how do I go down 5? Minus 5. Wouldn't that have been an easier way to write this problem? Don't you appreciate vertex form so much more now? You hope you always get it in vertex form. This was the standard form equation. You had to do all that algebra just to find that same result of write 3 down 5. Right? So you love the vertex form. Love it. Standard form is a lot of algebra. So just sometimes it's given to you in that format, right? I can't give it to you and guarantee you're always going to get vertex form, right? In the math world, it's a crapshoot of which one you get. In this case, we got standard form. All right, so I'm going to go right 3 and down 5. The rest of the process is now the same as what you already know how to graph. I'm going to show you in a minute how to use your C value to just double check that you did it correct. This is the concave up parent graph, right? So I'm going over 1, up 1, over 2, up 4, 1, 2, 3, 4, In this case, I'm going to go one more. I'm going to go over 3 and up 9. Let's see, I'm at -5, so that would put me at 4, and I'd be 4 over here. Now you could double check. Do you have the correct y-intercept? What's the y-intercept? The c value was 4, and my graph crossed at 4. So it's a way to double check for yourself. You went the right concavity, you went the right steepness, and you have the right vertex. So I always use this at the end to just double check. Yep, my y-intercept is at 4. So 0, 4, and I just checked on my graph that I ended up at the right place. So if you can do a standard form problem, you are the master. Standard form takes a lot of algebra skills to get correct. Don't be scared of them, but be ready to do your ABCs, right? Just know there's a lot of work involved for algebra for this one. And then when you see vertex form, you'll be like, oh, thankful for vertex form. Let's do one more together. This one is going to come out in a different direction. Let's identify our A, B, and C value first. So what's my A value for this one? -1. So when there's no number, the number is 1. So -1. What's my B value? +4. And C is -5. So